about, well, not really learn, but we have to make a miniature golf course, and this is something the entire grade is doing, not just math.
Okay.
A miniature golf course to raise an awareness for a problem in today's modern world. And apparently we have to make our golf hole be able to make a hole in one.
Okay.
What we were talking about here is that if there was an object blocking the way of the hole, which there has to be, how would you go about making it able to make a hole-in-one with being shot with using angles of incidence and angles of reflection?
Say the golf hole's right there, and here's where you're teeing off from.
Yeah.
Now, the one thing we know is that the angle of incidence is the same as the angle of reflection. In other words, if the golf ball strikes there, that angle theta is the same as that angle theta.
Yeah.
Well, hold on a second. That's not actually exactly true. That's only if that's a 45-degree line. In other words, if this angle is 45 degrees, then those two angles, the angle of incidence and reflection, are going to be the same. Obviously, if we design this thing a little differently, in other words, if you were to design it like this, now when you putt and it hits this, it goes more in that direction.
Yeah, it's going to be more obtuse.
Right, right. So in order to design your miniature golf course properly, you want to make this angle be 45 degrees. By that, I mean that has to be 45 degrees. And that's assuming that this is a right turn. In other words, this is a 90-degree turn. Obviously, if your golf hole goes something like this, well, now you need to design it a little different. But you have to make sure that you can hit a spot there that reflects into the hole.
All right.
And actually, even if the golf course was not designed properly, in other words, if this isn't at the right angle here, you could find some spot, maybe you'd hit it right there, not parallel to the sides, and that would cause it to go into the hole. Okay, so the top scenario is the easy one. It's where this is a right angle and this is a 45-degree angle, and that way you can hit a ball certainly parallel to the sides that will reflect off of that and travel parallel to these sides and go in.
All right. And what our teacher had us talk about was how we would go about measuring that without a protractor, which I think is kind of pointless, but I guess she wants us to learn it.
Well, the one thing we know in this picture up here is that this angle is the same as this angle. And that this angle is 90 degrees. Okay, so basically I would have to take this side right here, and there's my 90 degrees. What I really need to do is just bisect that angle. Remember in our last geometry session we talked about bisecting angles?
Yeah.
Is all that's doing is splitting that 90-degree angle into two.
So,
Now,
in order to make the right bank shot for the 45-degree angle one, you would just have to reflect the line, right? Kinda?
yeah. There's too many unknowns here. Has she drawn a golf hole for you?
Nope.
So she's just saying, make up a golf hole and figure out how to bank a shot into the hole.
Yeah, she just kind of made us shoot in the dark.
Okay. Well, the easiest way, in other words, you could certainly give a picture like that. That's going to be a lot harder to solve. So the easiest solution is going to be this one, where you make the hole turn 90 degrees, and you make that a 45-degree angle. The question is, how do you make a 45-degree angle? Is this without using a protractor? How about a compass? Can you use a compass, or has she even taught you about compasses yet?
No, she has not.
Okay. Because you can bisect an angle using a compass also.
Oh.
Yeah.
Oh, I get that, yeah.
Notice that if I had a right angle and I want to bisect that, so I want to figure out how to make a 45-degree angle.
Yeah, you would have,
Okay,
you would line up the
one end of the compass, the needle point to the compass there, the pin there, draw a little arc, use the same length and do the same thing there. Now put the needle there and draw an arc, and put the needle there and draw an arc, and this point bisects. There's your 45-degree angle.
Alright.
Okay? So that's the way you do it if you had a compass. If you don't have a compass or a protractor, well, then by making everything parallel here, you're guaranteed that that ball is going to bounce off that 45-degree angle, but you still have to be able to draw this 45-degree angle. So I'm trying to think of how you could ensure getting a 45-degree angle without a protractor or compass. Make a square. If you make a square and draw a diagonal, that's guaranteed to be 45 degrees. So all you would need is to, I'm not sure what she's looking for in asking you how to do this without protractor and compass. We haven't talked about doing that. As far as I know, you haven't talked about doing that. And we haven't even discussed doing it in geometry, but there are various ways you could do it without a compass and protractor and doing it precisely. I don't know. Maybe she just needs you to draw a precise picture. In other words, this angle that I drew here actually looks like it might be a little less than 45-degree angle. And of course, if it were a little less, this ball wouldn't reflect perfectly off of it. It would reflect more like this and miss the hole.
Alright.
Okay, so if that's perfectly 45 degrees, then you would want to aim your ball starting in the middle and make sure that it rolls parallel to both sides. And as long as it rolls parallel to both sides, and as long as that's a 45-degree line, it's going to automatically bounce directly and continue rolling parallel to the bottom two sides.
Okay.
Okay? Other than that, I don't know what to tell you on this problem.
Okay.
My audio sound any different to you?
No, not really. Well, a little bit. It sounds a little bit clearer.
You know, it sounds a little clearer to me too, but I moved my computer to a smaller room, and it's producing an echo effect almost. I feel like I'm in a sound room. But I was wondering whether you could tell any difference. All right. Do we need to talk about this problem anymore?
Nope.
All right. Let's go back and do some more geometry. We left off on number 6 last time.
Yeah.
Let's look at number 7. Hold on. So here's y, here's x, and there's z.
All right.
So now they tell us that x is 2z and y is 3z. What's the value of z? So what's the first thing I should do?
Well, we would turn the factors into y. No, not y, z. Sorry.
Z, exactly. In other words, they tell us that x is 2z, so I'm going to write 2z there. And they tell us that y is 3z. And now I can apply algebra to figure out what z is. What equation can I write now?
5z equals 180.
Good. Z equals 3 and change has to be 36.
All right.
At 30 and change. Okay? And this is more typical of geometry stuff, is where you end up having to do algebra. Algebra is as much a part of geometry as geometry is. Okay?
All right.
Okay, how about number 8? They want to know what is x in terms of y. Well, what equation can we write from the information that we're looking at?
X plus y equals 150.
X plus y, let's just write it like this, equals 180. Now you can say x plus y equals 150. So now solve for x.
X equals 150 minus y.
Right there. Okay. 150. Let's go to the next page. What equation can I write here?
1/2 x plus 3x plus x equals 180.
What's the next step?
4.5 x equals 180. And then
The next step?
you would divide that, and one moment. I got 40.
Okay. Is that doing it manually or using a calculator?
Using a calculator, I had to grab it.
Well, that's okay. There's nothing wrong with that. We're allowed to use calculators here. However, notice I can do something here that avoids the necessity of a calculator. And what would it be? Let me multiply every term in my equation by 2.
Oh, yeah, and then you could get 300.
Yeah.
Oh, right, yeah.
This, what it does is avoids the fractions. Okay, now I've got 9x equals 360, and I can do that without a calculator. 9 goes into 3640. A lot of times, if you have fractions in an equation and you don't want to deal with them, then immediately multiply by whatever the denominator is and multiply every term. You've eliminated all the fractions with that first step.
And number 10?
Yeah.
Well, it would be x plus 20 plus x plus 30 equals 180.
All right. I like doing it that way rather than trying to take a shortcut and subtract that 30 off right away.
Yeah.
Now what do we?
So then you would get 2x plus 50 equals 180.
Okay, now I can do that. Okay.
So then that means 2x has to equal 75.
65.
Oh, sorry.
It's okay. Always remember that if you're going to do this manually, and I'm going to divide 130 by 2, the first digit is 6. Oh, that'll save you from making that other mistake of coming up with 75. Okay. Have a look at 11. That's a pretty good problem.
Well, first of all, you would have to use, I forget what property it's called, but when one angle has to add up to 180 to get the other angle. So the triangle itself would be...
Well, the sum of the angles in a triangle have to add up to 180. In other words, this
that's
plus this has to add to 180.
Then all the angles outside the lines where it intersects with another line.
We don't need to worry about that yet. In other words, you're correct. In other words, if I look at this exterior angle right there, that's the sum of this one and that one. But that's not going to help us at this problem right here. We don't need to look at the exterior angles. And we could back solve it. In other words, we could test each of these as which is the biggest one and then figure out what the other two could possibly be and see if it's a 2, 3, 4 relationship. But there's a better way to do it. How about if we do this? Call that angle 2x, call this angle 3x, and call this angle 4x.
Oh.
Now, no matter what x is, it's a 2, 3, 4 relationship, right?
Yeah.
And I can proceed to solve for x, and then I'll know measurement of my largest angle. So how do I solve for x?
You would add it all together and get 9x equals 180. From that you get x equals 20.
And the largest angle, therefore, is
20. No, it equals, sorry, 80.
Okay. So let's just check and make sure that everything's copacetic. So if that's 80, this must be 60. And this is 40. And now let's check their relationship. Is that a 2, 3, 4 relationship? Yes, it is. So the secret to this problem was introducing a variable. The secret really wasn't geometry, it was using algebra. In other words, can't really solve it if I just put in 2, 3, 4, because that doesn't add to 180. So I just know that the sizes of these angles are in a 2, 3, 4 relationship. So I can add a variable because those angles aren't 2, 3, 4. They're 2 times some angle, 3 times some angle, and 4 times some angle. All right. Number 12, this figure here goes with this question.
All right. X plus y. So then, is this where you would have to...
You could actually use you could use that principle on this, I think.
So, yeah, I think so. We know that the top angle would have to be 40.
Okay.
Oh, wait, no. How would you solve this?
Well, you're right. You did the first step correct. Okay. And now what kind of algebra can I write? Let's put in a third angle right here.
Oh, okay.
Make up a variable.
What do you have?
And now what can I say? X equals what?
X equals 40 plus z.
Okay. And z, therefore, if I solve that algebraically, z is equal to what?
40 minus x.
X minus 40.
X, yeah.
Okay. Now, let's solve for z here. Z is also equal to what in terms of y?
Y plus 40?
No. Just these two angles right here. Z plus y equals what?
180.
Okay, so z must be...
Y, yeah, y minus 180.
Hold on, let's see. Let me get this straight here. We got y plus z equals 180. So z equals 180 minus y.
Yeah.
Okay, so if I've got z equals x minus 40 in one case, and z equals 180 minus y in the other, it's the same angle. So I can now say that x minus 40 equals 180 minus y. You see how I can leap to that conclusion?
Yeah.
And that's just solving a system of two equations. In other words, we had two equations here. So it's the same z, so I can set whatever this z equals to whatever that z equals. Now, we solve for x plus y.
Yeah.
What's it going to equal?
220.
Good. In other words, this is a case where we can't solve for either x or y. We don't have enough information. Okay? But we can solve for x plus y, oddly enough.
All right.
All right. That's probably a good place to stop for tonight.
Okay.
And
thank you.
You're welcome, and I'll talk to you next Tuesday. And I guess I'll talk to your sister at 6:30 here if she's around. Tell her that I'm planning on a session. If she usually has one, even if she doesn't have material, because she's trying to practice for SAT.
All right.
Okay, I'll talk to you next week, David.
Okay. Bye.
Bye.